Welcome to Carbon Chemistry channel. Today in this class we will see some previous year questions from NEET exam in some basic concepts of chemistry. Question is 25 grams of MCl4 contains 0.5 mole chlorine. Here 1 mole of MCl4 contains 4 moles of chlorine. So I can write per every mole of chlorine, so we have 0.5 by 4 moles of MCl4 molecule, right? Because 0.5 by 4, but 0.5 by 4 mole is how much weight? It is 25 grams. So 0.54 mole of MCl4 is having 25 grams. 0.554 mole MCl4 having mass is 25 grams. Then 1 mole MCl4 having how many grams? So this is 25 into 4 by 0.5. So it is around 100 by 0.5. So it is 200 gram per mole. So answer is second option. The element acts as a following isotopic composition. That's a given. So what we need to find out means average atomic mass we need to find out. So average atomic mass is equal to percentage abundance of isotope 1, its amount of molecular weight, plus percentage of isotope 2 into its molecular mass, and percentage of isotope 3 into its molecular mass by total percentage is 100. So what is percentage 1? 2 isotope 1 is 90 and its atomic mass is 200, plus isotope 2 percentage is 8 percentage, atomic mass is 199, plus isotope 3 percentage is 2, atomic mass is 200 by 100. 199.96 AMU, more or less it is equal to 200 AMU, the nearest value. So the answer is fourth option. Here the question is number of atoms present in 0.1 mole of a triatomic gas, and they are asking number of atoms. So number of atoms, before going to calculate number of atoms, first of all you should know Avogadro number is equal to 0.6.023 into 10 power 23 particles. Here particles could be atoms, but here we are talking about atoms, so I can write it as atoms. For triatomic gas is nothing but one molecule is having three atoms. But how many molecules we have? 0.1 moles. So now I can write moles of gas is 0.1, which is given. Now atoms of gas is equal to 0.1 mole, and each mole is having 3 atoms, and 1 mole is nothing but 6.023 into 10 power 23 atoms. So this we can write as, in simple formula, number of atoms is equal to moles into atomicity into Na. So this formula we can use directly. So 0.1 into 3 into 6.023, it is around 1.806 into 10 power 23. So the answer for 23 atoms, the answer is option B. Here the question is number of atoms in 560 grams of iron, and what we need to do is just we need to check which is equal to which of the given options. Means first of all calculate number of atoms in 560 grams of Fe. It is 560 by atomic number is 56. So 10 A number of atoms, 10 moles. So check which of the option which gives the 10 moles. If you take the first one, twice that of 70 grams of N2. 70 grams of N2 means 70 by 28 into 2. 28 into 2, it is 14, 70 by 14. 70 by 14, it is around 5. Around 5. Second option of that of 20 grams of H. 20 grams means 20 by 1 is 20 moles, and they said of by 2 is 10 A number of atoms. Coming to the third one, of that of 70 grams of C. 70 grams of C means 70 by 12 into of means 70 by 14, around 5. And fourth one, twice that of 40 grams of N. 40 grams of N means 40 by 14. So it is around 40 by 40 means 3 point something. So which is exactly equal to the 10 Na. So these two are equal. So answer 2 is correct. So the question is number of water molecule is maximum. So in this case what we should do is just calculate number of moles. If more number of moles, more molecules are present. The first option 18 grams of water. 18 grams of water means 18 by 18, molecular mass of water is 18. So 1 mole. So Na number of particle molecules are present. Coming to the second option 18 moles. 18 moles of water is nothing but 18 Na number of water molecules. Coming to the third one 18 molecules of water. 18 molecules of water means how many number of moles of water molecules means Na by 18. So this is Na by 18 moles. Coming to the fourth one 1.8 grams of water. It is nothing but 1.8 by 18. This is 0.1 Na particle. So which is highest one? 18 moles of water is highest number of molecules. So our question is the molarity of a solution containing 5 grams of NaOH in 250 ml of solution. So molarity, what is the molarity formula? Capital M is equal to weight of solute by molecular weight of a solute into 1000 by V in ml. So what is weight of the solute is given. The molarity of solution containing 5 grams of NaOH. 5. Molecular weight of NaOH is 40 into 1000 by in how much ml they have prepared? In 250 ml. So it is 4 times, 10 times and 1 by 5 by 10. So this is 1 by 2, 0.5 molar. So what is the answer? Answer B, option B is correct. The equivalent weight of a metal is 9 and the vapor density of a chloride is 59.25. The atomic weight of the metal. First of all, vapor density to molecular weight relation. So vapor density into 2 is equal to molecular weight. So molecular weight we can write 59.25 into 2, 118.5. Vapor density into 2 is equal to molecular weight, that is 59.25 into 2, 118.5. Now what is the equivalent weight of a metal is 9 and vapor density is given, and chloride, let the metal with chloride compound is MClX. Here the point, the logic you should remember is atomic number of chlorine atoms is X. So how many number of chlorine atoms are connected to the metal? That is nothing but its valency, or we can say equivalent weight. So now let molecular weight of metal is A. Now what we can say is X. So what is equivalent weight is given 9. So 9 into X means it is valency. So equivalent weight into the number of metals is nothing but X times plus 35.5 into X, because that is for chlorine. And what is the molecular weight we got? 118.5. So now X is equal to 118.5 by 44.5 is 2.66. Now molecular weight. So how many? What is the equivalent weight? 9. So each molecular weight is A. So now I can write molecular weight So option A is correct. The question is which has maximum number of molecules among the following. Maximum number of molecules, again repeated model question. Maximum number of molecules are nothing but maximum number of moles. Moles are directly proportional to number of molecules. Just calculate number of moles are present in each option. For example, option A, 44 grams of carbon dioxide. So 44 by molecular weight of carbon dioxide is again 44. So 1 mole. So 1 A number of carbon dioxide is present molecules. So 48 grams of O3. So 48 by oxygen molecular weight is 16, like the 3 atoms are there. Again 48, it is again 1A number of molecules. Coming to the option C, 8 grams of H2, 8 by molecular weight of H2 is 2, so 4 Na particles. Option D, 64 grams of SO2, 64 by molecular weight of SO2 is 64, again 1A moles of molecules. So which is having more number of molecules means option C, 8 grams of H2 is your answer. Here the question is given, a mixture of 2.3 grams of formic acid and 4.5 grams of oxalic acid is treated with concentrated H2SO4. So two compounds are there, they are going to treat it with concentrated H2SO4. The evolved gaseous mixtures are passed through the KOH. So gases are evolved and that is passed on the KOH pellets. The weight of the remaining product at STP will be. Here two cases are there. First one with formic acid, next one with oxalic acid. So formic acid HCOOH on H plus means in presence of H2SO4. H2SO4 is a dehydrating agent. So CO plus H2O is formed. So initially how many moles of formic acid is there? 2.3 moles of formic acid is 2.3 by molecular weight of formic acid is 46. So it is 1 by 20 moles. So after dissociation, CO, H2O is absorbed by H2SO4. So one COOH molecule means 1 mole of COOH will give 1 mole of CO2, means 1 by 20 moles of COOH will give 1 by 20 moles of carbon dioxide. So I can write, so initially I can write initially HCOOH is 1 and these are 0 0. So after 1 by 20 it is 1 by 20 moles are formed. Initially it is 1 by 20. So it is 1 by 20 moles of carbon monoxide is formed. So now number of moles of carbon monoxide is 1 by 20. H2O is absorbed by H2SO4. Coming to the case 2, oxalic acid COOH and COOH presence of H plus, again dehydrating agent H2SO4. It will give CO2 plus CO plus H2O. H2O is absorbed by H2SO4 and CO2 is absorbed by KOH, because KOH pellets is given. So what else we left with? Carbon monoxide. Now how many number of moles of oxalic acid? 4.5 by molecular weight is 90. It is also 1 by 20 moles. So 1 mole of COOH will give 1 mole of carbon monoxide. So I can write number of moles of carbon monoxide is 1 by 20. In the both the cases, H2O is absorbed by H2SO4 and CO2 is absorbed by KOH. What else in the mixer? And they are asking weight of the remaining product at STP they are asking. So what the remaining product? CO and CO. How many moles we have? Total moles of carbon monoxide is 1 by 20 plus 1 by 20. So 1 by 20 plus 1 by 20 is nothing but 1 by 10. The question is which case is the number of molecules of water is maximum. Again the same repeated model question, we need to calculate number of moles of each option given. For the first option 18 ml of water is given. Normally we can take density of water is equal to 1 gram per centimeter cube. So 18 ml is nothing but 18 ml of water is nothing but 18 grams of water. So number of moles of water is equal to 18 by 18, 1 mole. And then coming to the second option, 0.8 grams of water, 0.18 grams of water means what is the number of moles? 0.18 by 18, it is 0.01 moles of water. Coming to the third one, 0.00224 liters of water at 1 atmosphere and 273 K. 1 atmosphere and 273 K is nothing but STP. So 0.0024 liters of water vapors means how many moles? 0.00224 by 22.4 liters, it is 0.0001 moles. Coming to the last option, 10 power minus 3 milliliter of water. Actually this is mole of water. So it is 10 power minus 3 into how many moles is nothing but Na moles. It is around 1 by 1000, so 0.001 mole. So which is having highest number of moles? 18 ml of water is having highest number of moles. So answer is option A. Thanks for watching.